is very cold. The water starts to freeze. What happened to the ice, the frozen part of the river? Will it go to the top or to the bottom? Go to the top. Ice will form on the top. Ice. You know what this ice is doing? The ice is like a jacket, covering up the water, covering it from what? From the cold weather. Protecting, the ice is shielding the liquid water underneath. The ice is shielding from what? From the cold weather. So the water at the bottom is not feeling the cold weather. What will happen, listen to me, if the ice is more dense? Oops. If the ice is more dense, will it float or sink? Sink. If the ice sinks, will there be anything that will protect the water, the liquid water, and the fish? Now here we have the ice down here. Now this is the liquid. Is there anything that's going to protect the water from the cold weather? No. What will happen to the fish? The fish will die. So is it a good thing that ice has lower density than water? Fantastic, yes. Have you ever had a soda pop, a can of soda pop, and you put it in the freezer? What will happen to the soda pop if you put it in the freezer? Who did this experiment? They would do what? The soda pop would do what? The can would do what? Will pop, will explode. How come? It will expand. Don't do it. Don't do it. Got it? If you have soda pop in a can and you freeze it, listen guys. If you freeze it, it will expand, the can will explode. In your freezer, you will have 7-Up all over your freezer. Okay, if I give you that curve, and I tell you, look at line AB, will you explain to me that line? Will you tell me the relationship between freezing point and pressure? What would you say? The higher the pressure, the what the freezing point? The lower the freezing point. If I ask you why the freezing point is going lower, will you be able to explain it? What did we say about if we increase the pressure, what will happen to the structure of the ice? Breaks. What should the water molecules do? Reorganize. And that takes what? Heat energy, so the temperature goes down. Notice that unit about liquids, there is no problem where you can use the calculator. So what kind of question would I ask you regarding liquids? Explain and define. Define and explain. No calculation, no problems that can be given to you. All right, now let's go to the CO2 phase diagram. You have the CO2 at the bottom of page 5.
To vapor pressure right?
The chemical name for dry ice is CO2. So, I know the pressure is 1 atmosphere. What is the temperature of the room? Could it be lower than 57? Is the temperature right now lower than 57, do you think? What should be the temperature? Give me a guess, guys. 25, thank you. About atmosphere, what should be the physical state of dry ice? Yes. If you lower the temperature, what should you see? Gas and solid. If you lower the temperature, what do you see? Solid. Would you ever have a chance to see liquid dry ice? No. At higher what? Not temperature. Higher what? Pressure. Thank you. You hear that? Now you can see why I never had a chance to see dry ice as liquid. I'd love to see it in a cup. I would never be able to see it. For me to see dry ice in the form of liquid, I have to work at what pressure now? I have to work above 5.2 atmosphere. What should I be seeing here? Solid. Then solid and liquid. Then liquid. Liquid and gas. Then finally I see gas. So do you understand why dry ice sublimes? That's sublimation. If you want to see dry ice in the form of liquid, you have to work at higher than 5.2 atmosphere. What is this point here? This point is called triple point. What should be the physical state at the triple point? Hint, hint, triple, hint, hint. Solid, liquid, and gas. Every point here is a boiling point. Every point here is a boiling point. Every point here, what do you call that? I forgot? Melting point. Every point here is a sublimation point. I want to go to page 11.